one group of lipids, which were fatty acids, and now we can look at waxes. So waxes are basically just esters. So let's just review some of the ester chemistry. How do we come up with an ester? So if you take a carboxylic acid, so here you see we have a C double bond O with an OH, that's the carboxylic acid, and here's an alcohol. If we react this together, we're going to remove water, we're going to remove H and OH, and then this carbon is going to bond to this O over here, and you get an ester. So this is that ester linkage, that C double bond O with an O, that's our ester linkage, and now we have an ester. So the difference between the esters that we looked at in the past and the esters that are waxes, oh dear, I hate when that happens. So the only difference is that now we're going to have long chain fatty acids. So we can see that this is a pretty long chain. This one's short. You can continue to make this a little bit longer in order to get a wax. But the idea is the same. You're going to remove H and OH. You're going to get this ester, and there you go. So waxes are just esters made from fatty acids with long chain alcohol. So we're going to have long chains. You can have the long chain on the, so it's a fatty acid with a long chain alcohol. So long chains on both sides, pretty much. That's how you're going to get a wax. Um, so, right, so you're going to be given the carboxylic acid, you'll be given the alcohol. Can you find the wax? Can we draw that? We'll do an example of this, trying to draw that wax. You don't have to name them. Don't worry about naming these. The names get a little crazy, but you can see these are really long chains. There's 28 carbons in this one. There's like, so plus the first one in this one, but there's, I always look at that number to tell us how many we have. There's always going to be 2 more carbons in that. Same thing with this one. So that's 14 CH2 groups repeating over and over again. These things are huge. They're really, really long. There's a homework problem where I'm asking you to draw like the skeletal structure for, write the wax and then draw the skeletal structure. It takes up the whole page. So on a test, I'm not going to make you draw the skeletal structure. This is perfectly fine when you have the condensed form, as long as you can recognize that, like, you've got 14 carbons, 28 carbons. These things are really, really long, long chain fatty acids. So what are the functions of waxes? What are these purposes? You've seen these before. In plants, if you look at the leaves, like the top of leaves, you'll see that they kind of have like a waxy coating on them. That's to prevent evaporation. So protection, the main purpose of wax is protection. You're going to keep water in or keep water out. Feathers on, especially on ducks, like on any kind of birds that are in the water, waterfowl, those feathers are water repellent. Like there's a waxy substance on those feathers, and that prevents them from drowning. That helps them float, keeps them buoyant. This is why oil spills are so detrimental to waterfowl, because that oil is going to dissolve the waxes on the feathers. So remember, like dissolves like. So if you have something that's polar, that's going to dissolve in water. If you have something that's non-polar, it's going to dissolve in something non-polar. So if you put something like oil is going to be really non-polar. You fill that with water, all of a sudden the feathers, the waxes on the feathers are going to like talk to that oil, and the oil is going to start dissolving that layer, that protective layer of wax on the bird's feathers, and that's going to make them unable to stay dry and buoyant, and that's really sad. So that's why you see Dawn, we'll talk about soap later too. Dawn, like dish soap, and how they there's on some of those commercials. There's always like there's an oil spill and look, Dawn came and they saved the day because they were able to clean up the bird's feathers. And you're like, I've never washed a duck with Dawn soap, but it will do that. It will dissolve the oil, and then it will save the bird's feathers. So waxes have a protective function, and then the other one is an energy storage in microorganisms. We're not going to talk too much about that, but that is another possible function of a wax. So in microorganisms for energy storage. So can we draw this? You know how much I love to draw. So can we draw a wax? We're going to take a carboxylic acid. This is the carboxylic acid. I'm always going to write that one on the left, and then I have the alcohol on the right. I'm going to remove H and OH, and I want to show that ester linkage. So I'm going to do like a little mini snapshot of what we're doing, and then we'll fill in the blanks here. So I'm going to take this carboxylic acid, and I'm going to have this like long chain, whatever I have over there. And I'm going to take this alcohol, and I'm going to have a long chain whatever over there as well. And I'm going to remove the H and the OH, remove H and OH, and it doesn't matter which O you take there, but I'm going to make an ester. So I'm going to end up with a long chain fatty acid with an O, and then a long chain over there. That's what we're looking for. We're trying to build that ester. So what are the pieces that we're going to have at the end? We're going to take this, well, purple, sure. We're going to have this CH3, just change that, CH2, 14 with C. And I'm going to write out the carboxylic acid so you can see where we're coming from. And then we have an OH, CH2, CH2 16 with the CH3. And now I'm going to remove that H and OH, and I'm going to form an ester. So I'm just going to get rid of those, and I'm going to have this long chain fatty acid here. My CH3, the double bond O, O, CH2, CH2 16, CH3. So that is a wax because it's made from a fatty acid, which is just the carboxylic acid with a long chain, and then a long chain alcohol. So you end up having these two really non-polar sections. You have the oxygens in the middle, but you have something that is mostly lots of carbons and hydrogens. These could be you could have double bonds on these waxes as well. Like there, I just did single bond ones, but you could have other. You could really pretty much put any fatty acid there in any long chain alcohol, and you will have a wax. So let's see. Can we do the opposite of that? Can we hydrolyze this ester? Hydrolysis. And then when we saponify, saponification means this is going to happen under basic conditions. So basic conditions. That's what and this saponification comes from the word for how we make soap. So we'll talk about the soap making process and how you can turn these fatty acids and turn it into soap. And if you take Gob1 you'll do a lab on making soap. You'll make your own soap. So what we're going to do here to saponify this, just like we did before with ester hydrolysis, we're just going to bring it one step further. So this is our ester. I'm going to break this bond. I'm going to add H over here to get my alcohol back and an OH over here to get my carboxylic acid. And then I'm going to take it one step further. If I'm under basic conditions, this is not the form of that carboxylic acid that's going to exist. It's going to be in the carboxylate ion. So I'm going to have the base, the conjugate base of that carboxylic acid. So all that means is instead of having C double bond O with an OH here, under basic conditions, this hydrogen is going to come off. I'm going to have a C double bond O with an O minus. So under basic conditions, this thing actually becomes the anion. And if you remember, the whole purpose of reacting these fatty acids with a base is to make it more soluble. So this is going to make it more soluble under basic conditions. So the first thing I'm going to do is break that apart, find that ester bond, break it in half. I've got my CH3, CH2 with the 24, C double bond O, OH, and then on the other side I have my alcohol, CH2, CH2 with 48, and a CH3. Now, because this is being saponified, saponification just means it's under basic conditions, I'm going to get rid of that H and I'm going to have the anion instead. So this is an acid, this is the conjugate base. So under basic conditions, the base form of this is going to dominate. And so that's why I want to put that there instead. So that's going to be my answer. So take that ester, this is our ester, that C double bond O with an O, break that in half, get your carboxylic acid and your alcohol back. Remember, that's how we made these esters, right? We started with a carboxylic acid over here and an alcohol. We removed water. This is dehydration synthesis. You end up with an ester. And now all we're doing is we're breaking it, and then we're doing this under basic conditions. So we're going to break that apart. We get our carboxylic acid and our alcohol, but because the pH is high because it's basic, I'm not going to have that hydrogen there. It's not going to be there. It's going to be the conjugate base. All right, what class of lipids serve as an energy source and a protection against gaining or losing water? This is the one that we just talked about. This is just going to be a wax.